Welcome to Part 3 of the MC2105 Restoration Series. In Part 1, we learned about the history of McIntosh and some details about the MC2105 amplifier we'll be restoring. In Part 2, we recap the power supply. If you missed those episodes, you may want to go back and check them out. In this video, we'll recap and test the resistors on the input board, as well as address a modification that someone made to the unit. The input board provides the first two stages of amplification. In the left channel, the first stage is provided by transistor Q1 and the second by transistor Q5. Q3 is used to provide negative feedback to the signal. The MC2105 uses negative feedback extensively to reduce noise and distortion. The same takes place in the right channel with transistors Q2, 4, and 6. The input board has 4 electrolytic capacitors which are prone to failure and should be replaced. There are 4 capacitors which appear to be Mylars, which we'll also remove as replacements were provided with our kit. Later in the series, we'll test these to see if this was necessary. There are 2 ceramic capacitors on the feedback circuit. These are reliable, so we'll leave those untouched. 2 additional ceramic capacitors have been added to modify the feedback circuit. These are non-factory additions, and looking at the service manual supplied with the amp, we see a notation that states that these were added to, quote, reduce high-frequency megahertz oscillations. I'd like to eliminate the non-factory modifications made to this amp, so these ceramic caps will be removed. In upcoming videos, we'll test the amp for high-frequency oscillations, and we'll then determine if they're necessary. Let's begin. There are a total of 8 capacitors on this board that we're going to replace. And here I've gathered all the replacement parts from our kit that we're going to need to do the capacitor replacement on this board. The first thing we're going to do is remove the board from the chassis. So let's get started with that. Note that there are 2 nuts with star washers attached. And we also have these washers, which are... well, there's one. A little difficult to remove. Let me see if I can lift the PC board out now and make it a little easier to grab those washers. Okay, there's one. And there's the other. And we should be able to flip this around. Hopefully we have enough leeway with the wires so that we can get in there and remove these components. Yeah, the board looks great. And here we have our binding posts for the PC board, so those are still very sturdy. Okay, and if we position the board sort of like that, we'll be able to desolder the terminals that we need. Now, normally, I don't remove all of the capacitors at one time from a board just to be able to track things more easily. However, in this case, I've documented the board so well with photographs and drawings that I really have a good understanding of where the capacitors are going to go. So I'm actually going to remove all of the capacitors from the board right now. And the reason I'm going to do that is once the capacitors are out of circuit, we'll be able to test our resistors without having the capacitors affecting their value. So we'll get a better test and a better idea of where these values really are for the resistors. So let's go ahead and start removing all of the capacitors from the board. And why don't we work our way from right to left. Just turn this over here and let's begin. And I'm just going to mark very quickly with a marker the solder points that we need to remove. Okay, there's our first capacitor removed. Now they've bent the leads of these capacitors over, so I'm just using my tool here to sort of break that seal, the solder, okay, and to gently lift the leads to straighten them so that we can more easily remove our capacitor. I'm going to use the desoldering iron now to heat the leads a little bit and push them through. Let's move on now to the next capacitor. Note that the ceramic style capacitors we're going to leave in place and not replace. Okay, there we have it, all of the capacitors that we want to replace removed from the input board. Let's start testing the resistors. And we're going to start with these two here, which are supposed to measure 4.7 thousand ohms. Put our tester on here. Okay, and this first one is coming in at about 4.6 thousand ohms. Now note that these have the silver band, so these are a 10% tolerance. So we are within that 10% range, so that first one is fine. Okay, let's check its neighbor over here to the right and see where that one's coming in. Okay, now this one's coming in at only about 16 ohms. Okay, it looks like the issue might just be a loose connection here. So let's make sure, let's clean this up and make sure we have a good connection. Well, yeah, we're coming in at about 3.9 thousand ohms, and I don't know, still getting a bit of a rough connection here. Not very happy with that. Seems to be all over the place. Let's try it with our other tester, see if that makes a difference. On just a hair on the low side of 10%, so this one we're probably going to need to replace. Just going to mark that one with an X. Okay. And what I'll do is we'll keep moving on this, but I'll actually remove that from circuit and test it again to make sure. But looks like we might have a problem with that resistor, indeed. Okay, now these two resistors here, below the first two that we tested, are a 220 ohm resistors. So let's check those now and see where we're coming at. About 213, so that's within range. This one, yeah, there must be some capacitance in line here because, well, we're getting about 230, 220 ohms. I think that one's probably close enough. Let me flip it over and give it a try. $214. 215. Yeah, those are fine. All right, let's move on now to this resistor here. And this is R5, I believe. And this is supposed to measure 470K ohms. 380K. That might be a little on the low side. We do get a difference if we test on this side of the board, so I think we're just getting a better connection here. 485,000 ohms, and that is fine. So this one is 4.7 thousand ohms. Let's test that one. 4.5, that's fine. This one is supposed to measure 100. thousand ohms. 107, that is a silver capacitor, so it's fine. It's a little high, but it's still within the 10% range. This one, 22K, and we measure just about 22K, excellent. This one is supposed to be 470 ohms, and we're at about 460. A little on the low side, but still very much within that 10%, so that's fine. Here we have a 120,000 ohm resistor. Okay, I'm going to mark that one too to check. I'm guessing this one's so far off. I'm guessing when we actually remove it from the board to test it that it'll be fine. But let's mark that one as to check. Okay, let's move on. We have another 120K here. Also coming in at just 20K, so we'll have to pull that one too to check. Here we have a 470 ohm resistor, and we are very close. That one's fine. This one is supposed to be 22K, 22,000. Let's see. Pretty much right on the mark. Excellent. This is 100K. Yep, very close. 470K. Yeah, definitely on the low side. I'll pull that one too, just to double check. That one doesn't seem quite right. 4.7K, this one's measuring just about right. Okay, so let's take a look at our results here. We see that we have a 4.7K resistor here that we're going to check, a 120K resistor here, and another 120K, and a 470K. Okay, so a total of 4 resistors that we're going to pull from the board and double check. Okay, let's pull this 4.7K first. I'm going to turn on the fume extractor. Okay, now that we have this 4.7K resistor out of circuit, let's see how it tests. And you can see it's coming in at about 4.615 thousand ohms, and this is actually just fine. In circuit, it was testing as faulty and giving us some strange readings. But again, that was just a consequence of it being in circuit. And now that we've removed it, we can see that this resistor is actually working just fine. Okay, I've got the 4.7K ohm resistor reinstalled. And let's move on to this 120K and see what's going on here. Okay, we have our 120K resistor removed. Let's see how it tests out of circuit. Yeah, just about 123K. So this resistor also is absolutely fine. Again, testing very strangely in circuit, but out of circuit reveals that the resistor is actually just in just fine condition. So I'm going to put this one back into circuit as well. Okay, I've got that 120K back in service here. Now note that we also had a matching 120K resistor here that was testing strangely. Let's just confirm that in circuit they test about the same, and if they do, then we'll know that this resistor is going to be just fine as well. So in circuit, this 120K ohm resistor measures only about 10.8K ohms, and this one about the same. So again, in circuit, these resistors are measuring about 10.8 K ohms, and so those are both fine. So we have one last resistor to check. This 470K ohm resistor was testing as faulty in circuit. Let's pull it and give it a try as well. And I'm pretty certain that we've tested all of these resistors now, and they've all checked out fine. It's very highly likely that this one is just fine as well. But let's pull it just to confirm. All right, our 470,000 ohm resistor is coming in at 490,000. Absolutely fine. This one is fine as well. So we really did not detect any faulty resistors. So far, every resistor that we've checked on the amplifier has checked out just fine. So good to know as we move along that these resistors are actually very reliable. Okay, let's move on now to getting the new capacitors installed in the input board. In this container, we have the new capacitors, and in this container, the old ones. Now, we're just going to replace all of the capacitors on this board. As with the resistors, some of these capacitors may test just fine. I suspect these, for example, are probably going to be just fine. But we're going to replace all of them anyway with new ones just to be on the safe side. But towards the end of the video, we'll go through and we'll check most of the capacitors that we pulled just to see really where they stood, if they did need replacement or not. Okay, let's start from left to right. In this position here, there was originally a 500 microfarad 16 volt capacitor. And let's see, that was this guy here, 500 microfarad 16 volts. And our replacement, 680 microfarad at 25 volt capacitor. Okay, now these are electrolytic, so it's important that these are put into position with the polarity correct. Okay, you can see on the board here I've marked red for positive, and I have the manual for the service manual for the amplifier as well, and I have the sheet here which I've marked up as well. Okay, and this is one we're talking about here. Okay, and you can see it's positive, negative. Positive, negative. I'm going to start by straightening my leads nice and straight. Now you want to position these so that you can see the writing as best as possible. We don't want to install this with the writing down. We want to be able to look back and confirm that this is the correct capacitor that was installed. And I'm just going to roughly mark on here where if I center this between the two holes, I'm going to put a little dab of ink right about there and a little dab of ink right about there. Okay, and that roughly gives us where we want our capacitor leads to bend downward. Okay, now let's slip that in place. All right, and that's going to go pretty much like that. So let's see, flip over our board and just give a little pull on that lead and bend it over. We won't solder that in yet. We'll get all the capacitors in place and we'll double check their positions, and then we'll solder them all at once. Let's move on now to this position, and you can see here we also had a 500 microfarad at 16 volts. And again, we're going to replace that with the matching 680 microfarad capacitor at 25 volts. So the same thing. But note here that the positive negative orientation is different. On this one, positive was facing top, and this one the positive is facing negative. And you can see that I've marked a little red dot here to indicate that. We'll do the same as we did in the other one. Okay, we have our first two electrolytic capacitors installed on the input board. Moving on, we see that our next capacitor is C3, which comes in at 0.47 microfarad. And our replacement also comes in at 0.47 microfarad. And this one is rated for 250 volts. The original was rated for, looks like that was also rated for 250 volts. Okay, so a little bit different style here. They do have this line here, which may or may not indicate the foil side of these capacitors. Even if they were, McIntosh had not installed them, that they would be connected to the ground point. So McIntosh didn't really pay any attention to the foil side, obviously, of where the capacitors would go in this case. However, I have tested both of these replacement capacitors to detect the foil side. And in both cases, they are on this side here. So I've marked the foil side with a black dot, and we're going to put that to our ground point. Okay, so the signal will come in on this side, on this side, and flow through. So what I've done here is I've marked the circuit on this board. Okay, we've got one here and one here, and just a little negative mark here, and that's where our foil side is going to go. Okay, so let's start with our first one, and we have our foil side here, and I'm going to orient that in that position. Okay, again, our black dot and our negative mark for foil. Bend those leads over to hold that in position. And why don't we move on now, jump to the other one. It's matching capacitor over here in this position. Okay, you can see that one is here, the 4.7. And again, the dot is going to face on this side. spin that over. Our next one we can see is going to go here, and you can see I've marked it with a red dot. So this is an electrolytic, and let's check our diagram. C11. Okay, and the original was 100 microfarad at 15 volts. Okay, and its match over here is C12, 100 microfarad at 15 volts. Our replacement is going to be 100 microfarad at 50 volts. So we have two of these. 100 microfarad at 50 volts. So we've upped the voltage a little bit. Absolutely not a problem. A little bit higher as far as the voltage is going to be just fine, and it's a good idea. It's always good to have a little extra capacity for voltage. Now these are marked for negative and positive. Obviously these are electrolytics, and our little crinkled end here with the indent is our positive, and our negative you can see points this way. Our two 100 microfarad electrolytics are now in place, and looks like we have capacitor here, and another one there. Let's take a look at these two here. Looking at our diagram, you see that we have a 10 microfarad at 25 volts and a 10 microfarad at 25 volts. Okay, these two match here. And these are bipolars. Okay, here we have some bipolar electrolytics it looks like they've given us to replace that with, and these are 10 microfarad at 50 volts, and again the originals were 10 at 25 volts. So again we've increased the voltage capacity from 25 to 50 volts, and that's absolutely fine. So these can go in either way, and I checked these on the oscilloscope to see if I could detect a foil side, and I really couldn't notice any difference. So. This one I've noticed that the way I oriented it, the writing's kind of small, and I thought I had oriented it so I could see the values, but actually I haven't. So I'm going to remove this one. There we go, much better. Make things easier for the next guy who's going to be in here doing repairs, so we can actually see the value of these components. Okay, and it looks like we have one more here, and that is... Actually, no, on this one, there was a capacitor that is sometimes used. And apparently on later models, later serial number versions of this amplifier, there is a capacitor here. I checked the notes on this. This unit is a lower serial number, so it actually does not use the capacitor here. And yeah, we can see, we'll double check, and our container is empty. So we do have everything in place. Let me just double check my work here. One thing that I've just noticed, okay, you see here what this lead, this green-white lead, because we've been twisting this back and forth, this got disconnected. And we can see that it goes here on the board. So we're going to need to repair that as well. Okay, so just take note when you're working on this. Some of these connections could possibly break as you're doing work on this, particularly if you don't remove the board completely and you're bending it back and forth. So yeah, do double check and make sure, and I'm glad I noticed that. Let me set that aside so that sticks out like a sore thumb and I don't miss it. Okay, let's continue to double check the work here. Everything looks good. Let me flip the board over and we'll solder these new capacitors in place, and then we'll address this problem as well. Okay, our soldering iron is heating up, and I just want to show you, I just attached some clips here to hold the board in positions, lay it flat so I can work on this. I'm going to turn on the fume extractor, and let's get these new capacitors soldered in place. Okay, everything looks good. We've got some nice shiny solder joints here. Let's remove the excess leads. Okay, everything looks great. Let's clean up this board a little bit, remove some of that flux. Okay, great. Nice and shiny. My voice might sound a little muted right now. I have a mask on to help with the fumes from the alcohol and the flux off. Yeah, so we got the board nice and cleaned up. Note that McIntosh did a good job removing the flux from this board. You can see didn't really have to clean up much of any flux that was left on there. There are a couple of other places they did leave a bit of flux on there, so we'll do our best towards the end of this restoration to clean some of that up. Okay, let's see what we can do now to reattach our lead here. Actually, it looks like we have two broken leads. Okay. Okay, it was a little rough apparently, but we're going to fix that now. Okay, so we have a green-white lead that fell off and a green solid lead. Okay, and you can see that the 2 points where they fell off from were here and here. So I'm going to need to consult my photographs to just confirm that we've replaced these into the correct terminals. First thing we should do though is try to remove this solder from in here. These are kind of posts where the wires fit into the hollow area inside. So let's suck that out so that we can start clean and get these stripped and get some fresh wire in there. Okay, so I'm not really, I haven't had any luck clearing out these terminals because the old wire is still in there. So I'm going to see if I can kind of drill these out a little bit to remove some of that wire that's still in there. Just going to use these very tiny and sharp drill bits here and see if I can't use them to extract the old wire. Let me try a smaller one. Yeah, I'm not loving this. I think what I'm going to do, the best thing to do in this case is let's flip this over and desolder these posts and just put our wire directly on the board. Okay, we've got the 2 posts removed. Hopefully not too hot. 1, 2. One of the reasons why I stopped drilling that out is because it was creating some metal flakes coming from the drilling action. So I can see that there's a couple little bits of metallic flakes here in the bottom here. And I'm just going to vacuum that out before we go much further. And additionally, I'm going to use the electric duster to blow that out. Okay, let's strip these 2 wires so we can get them back in place. Okay, and if we consult our photos to see which wires go where, we see that on the outer one we have the solid green, and on the inner one the white green. Let's get this board back in place now. Let's just check our original photograph and compare. And mostly right now I'm concerned with the way these cables were oriented. You can see this one here is now kind of above and going that way, and it appears originally all of these cables went underneath that board. So let's lift this board up and tuck those cables underneath completely. Probably trying to get those cables as close to the chassis as possible for shielding purposes so they're not hanging out here. Let's make sure none of these other wires got loose before we go too much further as well. Everything looks good. What I would recommend if you're doing this and you want to avoid having these wires come out, I would cinch these wires together with the wire tie just to strengthen them so that they kind of work together as a team. And I'm going to do that now. Add a wire tie there. Okay. Yeah, if that cable tie were like that in the first place, I doubt we would have lost these cables here. Let's go ahead now and add our washer and a nut with a star washer, I believe. Yep. Notice there's a ceramic capacitor bridged over this resistor here, and another ceramic capacitor bridged over this resistor here. these are not original. Somebody has apparently added these to the circuit. My goal is to return the amplifier back to original as much as possible, so I'm going to consider removing these. Now, why were these capacitors installed? Well, looking at the service manual that I have for this particular device, I noticed that somebody has added the notation on the schematic for the input board that a 0.001 capacitor was added here and here to reduce high frequency megahertz oscillations. Now, I have not read any reports of any high frequency oscillations with this particular amplifier. So what we're going to do is we're just going to simply snip these away. And in testing, if we find that we do notice some oscillations that we can't hear but are driving the amp into to working for no reason because of some type of oscillation, then we can look into reinstalling these. But right now I'm going to snip them and get them out of circuit. And instead of desoldering these, I think I'm just going to simply snip them off. So let's do that now. There we go. That wraps up part 3 of the MC2105 restoration series. Stay tuned for part 4, where we'll move on to the meter board, output boards, and more. To stay updated, subscribe and click the bell. And if you like this video, please give it a thumbs up. I'll see you soon.